All right, so what we're looking at today is water in the water cycle. So, if you look at a map like this one here, what you should notice is that there's a lot more blue on there than there is green or brown. All right, so what that tells us is that the Earth's surface is mostly covered with water. And in fact, water covers over 70% of the Earth's surface. Now, where is that water? All right. Well, most of the water on the Earth is located in the oceans. So about 97% of the water on Earth is located in the oceans. However, for most of our uses of water, that's not really useful to us because the water in the oceans is salt water. And if you think about what we use water for, drinking, can't drink salt water, it's poisonous. Watering crops, can't water crops with salt water, it'll poison them. Cooling machinery, well, salt water is really corrosive. So most things that we use water for, salt water you can't use. So that makes the fresh water, which is water without any minerals dissolved in it, or very few minerals dissolved in it, that much more valuable. So only 3% of the water on the Earth is fresh water. Now, which seems like a tiny fraction, but it's actually even less than that. And the reason being is, if you look where the fresh water is located, most of that 3%, about 3/4 of that 3%, is located in glaciers. And if you think of where the glaciers are located, well, you have the most glaciers are in Antarctica and Greenland. Well, in Greenland, it's a fairly big landmass, but there's only like 50,000 people live in Greenland for all that water. So it's not really useful to the other 7 billion people on the Earth, that all that water on that island with 50,000 people. And the other place, which has the most, is Antarctica. Some of the glaciers there are several miles thick, but again, no one really lives in Antarctica. There's scientists who may be down there for a couple of years, but it's not like they're, that's not like their home. They're just there doing research. So there's a tremendous amount of water tied up in ice, most of which is located in places where you can't really access very easily or nobody lives. Now, there are some mountain glaciers, which are much smaller glaciers. There's basically two types of glaciers. You have the ones that could form in the mountains, which are fairly small, and the ones that can form on the continents, which are the big ones. The ones in Antarctica and Greenland are the continental glaciers, are really big ones, but not a lot of people live there. The smaller mountain glaciers or alpine glaciers, for some of those, there may be cities nearby that can use water melting off the glacier. But again, that's just a very small percentage. So most of that water is tied up in glaciers we can't use because it's in places where nobody really lives. Next down on the list, groundwater. That's actually where probably most people in the world get their drinking water, from groundwater. So that would include springs or if you're digging a well. All right, so groundwater is 23%. Now, what you typically think of, where you might get your water from, lakes and rivers, actually only a very, very tiny percent of water is found in lakes and rivers. Less than 1% of all the fresh water on the Earth. Now, for us in upstate New York, sometimes we don't appreciate that because we happen to live in an area that has an abundance of lakes. We have the Finger Lakes, which are all pretty big sized lakes. A little bit farther away, we got the Great Lakes, like Ontario, Lake Erie. So we live in an area that has lots of lakes. Most of the world is not like that. Most of the world does not have very many lakes whatsoever. Because there's really only a few ways in which lakes can form. You can have like a crater from a meteor hitting or something like that could cause a hole that fills in with water, or you might have a volcanic crater fill in with water, or a sinkhole fill in with water, or where the lakes that are found in New York State, most of those are caused by glaciers. Glaciers kind of scoop out areas that end up filling in with water. Now, since New York State was covered with glaciers like 10,000 years ago, most of the lakes that we have are the result of glaciation. So the places that have lots of lakes, Minnesota, Michigan, Vermont, places like that, were all places that were covered by glaciers in the last ice age. But most of the world's not like that. You go into southern states, in Pennsylvania, there's not a lot of lakes in Pennsylvania because the glaciers, last time the glaciers came down, they got to about the New York-Pennsylvania border. In Pennsylvania, or Virginia, or West Virginia, there's not a lot of lakes there. What lakes are there are usually man-made lakes. They just dammed up a river. So lakes are a fairly rare feature. We just happen to live in an area that has lots of them. And rivers, by and large, in the grand scheme of things, of all the water on the earth, really don't have that much water in them. Now, the atmosphere has got less than 1% too. A lot of water goes through the atmosphere, a lot of water evaporates up in the air, and a lot of water comes out as rain. But at any one time, relatively speaking, the air doesn't have that much water in it. So I like to think of the atmosphere as being like a doorway. During the course of the day, a lot of people go in and out of that doorway, but at any one time, and it's important, but at any one time, there's not very many people actually in the doorway. That's kind of what the atmosphere is. A lot of water goes up, a lot of water comes down, but the amount that's actually being held in there compared to the amount of water in the earth is actually pretty small. All right. So the water that we can most easily access, the lakes and rivers, again, that's less than 1% of all the fresh water in the world. That's why it's really important that we don't pollute those and maintain those water resources. But anyways, the water moves back and forth from places on the Earth's surface. And the model that we use to show how the water moves back and forth in these places, we call the water cycle. So the water cycle is a model showing the movement of water from one part of the environment to another. Now, because it's a cycle, I can really start describing it in any one location. Because if I describe it in one spot, it's just going to kind of work its way back around. So I can really start anywhere describing it. But let's say I'll make a little drawing here. All right. So first step, precipitation. All right. Precipitation is when moisture is falling from the sky. So primarily rain and snow. Sleet, hail would be precipitation too, but rain and snow are the two big ones. So let's say I have some rain over here and some snow over here. All right. Now, the process that makes the clouds that allowed it to rain and snow is condensation. So condensation had to happen before the precipitation did, because during condensation, the gas turns into little water droplets, and that's what makes clouds. And when those water droplets get so big, that's when they start to fall out as precipitation. So condensation makes the clouds. Precipitation is when the water droplets get so big, or ice droplets get so big, they can't stay suspended anymore, and they start to fall from the sky. Now, when that water hits the ground, there's several things that can happen to it. One thing that can happen to it is it can hit the ground and it can just flow across the surface like that. All right? You hit the ground and just flow across the surface like that. When water flows across the surface, we call that runoff. All right? So runoff is water flowing across the surface. And runoff happens most frequently either when the land's really steep, or if the ground is covered with something like blacktop, or if the ground is saturated and it rains, there's no place in the ground for the water to go, so you get lots of runoff then. Another thing that happens with the rain when it hits the ground is it can soak into the ground. All right. When it soaks into the ground, it's called infiltration. All right. Now, there's a number of factors that affect how much water infiltrates, and again, how steep the land is. When the land's flatter, more water infiltrates. When it's steep, less water infiltrates. How porous the ground is. So something like sand would let a lot of water soak in. With concrete, you wouldn't have very much water soaking in. So things like that affect how much water infiltrates. Some of the water gets absorbed by plants. All right, so plants soak in some of the water from the ground. All right. So now the runoff a lot of times goes into lakes or rivers or ponds, stuff like that. Infiltration goes in the ground, and then the plants absorb some. So now how does the water get back up into the atmosphere then? Well, one way the water gets back up the atmosphere is by transpiration. Transpiration is when plants, they soak up water from the ground, and then they end up releasing water through their leaves. All right, that's transpiration. Now, in some areas, transpiration can release tremendous amounts of water in the atmosphere. Because you think about like a typical maple tree, and if I took all the leaves off a maple tree and then laid them out flat, that's going to be, now I measured how much surface area that is, that's going to be a tremendous amount of surface area that's releasing water to the air. All right, so transpiration can, in some places, release a lot of water into the air. An easy way to remember that one is that trees carry on transpiration. Evaporation is when liquid water turns into a gas. All right. Now, normally you think of evaporation being like water coming off the ocean or water coming off a pond or something like that, but it could also be water coming off of the wet ground or puddles, stuff like that would be evaporation as well. So evaporation going from liquid to gas. The last way is sublimation, and sublimation is when snow and ice turns directly into water vapor, so it skips the liquid phase altogether. And sublimation is a much, much slower process than these other two. And if you've ever made ice cubes and you put an ice cube tray in your freezer and you forget about it for a few weeks and you pull it out, you notice the ice cubes should have shrunken quite a bit. And what's happened is, well, they didn't melt because they're in the freezer, is that the ice cube shrank because they sublimated. They turned directly into a gas. When something gets freeze dried, like if you put some pieces of fruit in your freezer and you didn't have them in a plastic bag, you just put them in the freezer, after a while they'll freeze dry, they'll sublimate and they'll just become like dried fruit. Okay. So those are the various components of the water cycle. Again, because it's a cycle, I could really start describing it anywhere. And later on in this topic, we're going to look at a few of these things in more detail. We're going to look at infiltration in a lot more detail, and we're going to look at runoff in a lot more detail. All right, but that is the water cycle.